So I just wanted to show you my CNC machine. It's a Lowrider version 2 from V1 Engineering, and I have made some modifications to it, as you can see, and I just wanted to walk you through some of them. I guess let's start with the obvious second floor to the x-axis, because in the original design there's only the lower part of the tubing. The reason I added the second floor is because it adds some structural integrity. As you can see, before this was a pivot point, and you could push the whole construction. It would well, basically it lacked some bracing in here. I didn't want to add any braces here because I would lose the x-axis length, so I tried to think of the ways I could brace it some other way, and the solution was this. So it makes sort of a box, I guess, because now if you move this way, there are 2 points that hold the axis on the place, and it's much more rigid than before. The second modification, as you can see, I have made 2 plates for mounting the tools. The lower part is also a redesign. It's much wider now. I lost some X length, but not as much as I would otherwise. I added a dedicated vacuum hole. There is a custom spindle brace, and also I added a mount for laser. And the second floor of the x-axis holds in place the spindle from the top, because previously I had issues when milling wood, and the spindle would go in the direction of the wood grain. Then the spindle end would follow the grain as it would traverse the x-axis, and it would twist the top part. So basically, again, this would be the pivot point, and it would follow it like this. So I needed to brace the top part of this to eliminate this effect. And in the end, I guess yeah, it's much better than before. The spindle itself is 1.5 kV spindle driven by the variable frequency drive here. At first I thought about maybe buying the water-cooled version, but also it was more powerful. But true matter of fact is that this power that this spindle has is plenty for this application, and I believe at max loads I'm loading it only about 25% maybe, so no issues with that. And the other thing about water-cooled spindles is that I live in a region where there are cold winters, and this workshop is not that well heated when I'm not here, so it would cause some problems, I believe, with the cooling system when it froze. So yeah. About the laser itself, it's a well, it's advertised as 15 watt blue diode laser, but I'm kinda doubtful about those 15 watts, because I'm getting similar performance as I have seen other guys on YouTube that are running 2.5 to 3 watt lasers, but I haven't made any measurements and I can't tell. The only measurement I have made with it is that well, it's not a measurement, I guess it's a test. I tried to cut Baltic birch plywood. I guess the 4mm thick wood was cut after 10 passes, and also barely, so it's not really for cutting plywood or wood in general, but it makes great engravings. So in the end, this is not a laser engraver, but just an option if I would need to mark some parts that I have cut. So about the axis motors, I'm using NEMA 17s, but the most beefiest that I could find. Those are 65 Newton centimeter torque and up to 2.1 amps of current while installing. They're great, I have no complaints. Well, yeah, I guess they could be more powerful like NEMA 23s, but again, this construction and this design, I guess, doesn't need it as much as some other modifications. To drive the x-axis, I'm using dual NEMA 17s. Both are the more torquier ones, the 65 Newton centimeter ones, and the y-axis is driven with the, well, you can see it there, but those are, I know, well, when you can see it, those are the bit smaller ones. I forgot from my head what torque those were, but yeah, those are smaller than the y and the x-axis ones. At first I was running them from those small 3D printer drivers, but in the end I decided to run them a bit closer to rated current, and I installed, just a minute, yeah, this is the control box. It's a bit sketchy, but it works. So yeah, the control box. Now I'm running the TB6600 drivers. For the x-axis, I'm running the motors in parallel. Other ones are individual. The whole CNC is controlled from the MKS board, Gen 1. Not the Gen 1, Gen L version 1, but I guess they're similar in all other versions. And one peculiarity about these motor drivers, that after I had bought them, I came to observation that they tend to be in two variants. One is I forgot which one is which, but basically you got the ones with the +5 volt signal pin, and the other ones are with the ground signal, basically cathode or anode common. And I had the ones with the +5 volts and had to be creative with how I connected them. Basically I'm picking up 5 volt signal, I don't know if you can see it, from the board pin oh, not the board pin, I'm getting it from this the inbuilt motor driver seats from the, I believe it's the second pin from top on the right side, and the other signals are from the auxiliary outputs next to the motor drivers. I think I will add some description down below in the description area how I did this. And for the laser also there was a bit confusion, because at first I thought I could just hook it up to fan output, but I ended up connecting it to the auxiliary output pin 44 in the second auxiliary contact group. But I'm no electronic engineer and also not a programmer, so I will leave some links down below on the guys that have sorted this out. Some old guy coding had great video about the laser connection, and I will link it. Yeah, this is the Raspberry. It runs the Atmega board, and via local area network I'm controlling the whole CNC through Octoprint software on my old. So this is the 24 volt DC bus, plus and minus. This is the 12 volt, and over here this is the 5 volt DC bus from the well, it's the common 5 volt signal for the motor drivers. So what else? Oh yeah, I'm running end stops both on Y as well as Z axis and on X axis also. The end stop mounts are, I guess, a bit sketchy, but well, they work for me really good, and I have seen guys that are doing them with the adjustable set screw that you can adjust each axis, but I thought to myself that at most I will do this adjustment maybe 3 times, 4 times in the year maximum, so I just went with the quick design and quick zip tie solution to the end of the rod. As you can see, the whole signal is wired through these screw terminals, and the motors are soldered directly to the wire ends. This was not the case in the beginning. In the beginning I was I had it all connected through these. I'll show you quickly. Through these, I forgot the name of these ones. I believe it's a type of a Molex, but I think you have also majority seen these. These are well, the story is that when I had problems with these connections. Well, they were a pain in the ass to assemble, and they were pain in the ass to diagnose and also repair. And also, at first I was using the LED strip cable, and this was a poor match between those, because I believe the diameter, outside the diameter of these leads didn't quite match with the designed diameter for these connections, and that's why I had the problems. but in the end I just went for the ferrules and this wonderful device. This makes great terminations of the cables, and I have no issues with that anymore. About the dimensions of this machine, I'm running somewhere between 200 and 250 workable millimeters in Z. I don't quite really know how precise it is because I haven't had any issues with the Z height. I believe I designed the height to be at least 200 millimeters, but with all the second floor modification and spindle mounts and everything, I believe I have lost the exact workable Z height. X is 950 millimeters, and Y is basically 1.5 meters. But as you can see by these cut marks, I rarely use more than maybe a meter, maybe a bit more on the Y at the moment. But I have had some cuts that approached the Y-axis limitations. As work mounting, I'm using just 35 millimeter Baltic birch plywood. I got it for a really great price, and then I'm just mounting it on the floor of the table, and whenever the surface gets when the surface gets too demolished, I guess, then I will just flip them and flip them across the Y direction, and well, yeah, I believe it's the cheapest solution, because on my other machine, on this mostly printed CNC, I'm running with I guess these are the T-nuts. Yeah, and they were expensive as hell. I ended up not filling every hole, but only the perimeter and some middle holes, because they were some, like, for the whole set I paid something like 30 to 40 euros, and I guess if I tried something like this on this big table, then yeah, it wouldn't be that economical. So yeah, what else? Money wise, I believe I have spent somewhere between 600 euros to 700 euros all in all. But I believe if I would not rebuild it every 2 weeks, then I guess you could do the whole thing with the custom spindle and custom motor drivers and the bigger motors and everything and the lasers. I guess you could manage to get it into 500 euros. So far I'm very satisfied with it, and yeah, I'm looking forward to work with it. If you have any questions, be sure to ask me, or maybe you've seen something that's critically wrong about this whole setup, then let me know. And yeah, thank you for watching.